Okay, so 2012 ordinary level, question B2, table tennis table, and it is perspective. So, bits of information. We have the spectator point is 70 millimeters away from corner A. This is corner A here. The picture plane is touching corner A, and the horizon line is 80 millimeters above the ground line. The angle here is 30 degrees. 30 plus 90 is 120, or 60 degrees from horizontal. So what we're going to do is up in the top right hand corner is where we're going to draw the plan view. So we'll start with that. Okay. Again, there's no scale on this question, it's 1:1. And the overall dimension is 65 and 65, which means that is 130 if I'm good at my maths.
So you might be showing it on the board? No?
I think I am, yeah. Is it frozen? Thank you. Okay, I'll just turn out the lights here as well, just to make sure that we have just an electric shock from the switch. That's good. Okay. And turn on the light on this, which is where? Okay, so I have my 130. Come down vertically, measurement of 80. Again, you don't have to do it this way. If you prefer, if you wanted to try it to have the page in a portrait situation and draw it as the question is given to you, you can do it that way. I just suppose I'm in the habit of doing this, so habits are hard to break, as to say. Again, it's just a nice simple rectangle for the plan view, which is great. And then we have the underneath of the table that we need to accommodate for. Again, these lines are going to be in hidden detail. Okay, and then we go 60 degrees from corner A. Remember, label everything as you're going along. Corner A, 60 degrees, and the measurement out then, according to the question, is 70. So mark that in. Spectator. Furthest point on the left comes to the eye of the spectator. Furthest point on the right to the eye of the spectator. Now, just a little bit of a change in this question, okay, just because it's, you know, a little bit more advantageous for you, but it has given you the position of the picture plane, so it's telling you that the picture plane is at 30 degrees here and 60 degrees to this side. So again, if you wanted to use your set square for that, rather than doing the usual setup that we do, I'm just going to use my 30 degree set square here, 30 degrees from horizontal, and I'll draw in my picture plane.
So you don't have to do the whole lot of
no, not in this question, because it gives it to you. Okay, but if you were doing a higher level question, it wouldn't give it to you, and you would have to do it, to be honest with you. Okay, so that's our picture plane again at 30 degrees here, because that's what it gives us in the question, and then that's at 60 degrees again, because that's what gives us in the question. Now, to find the vanishing points of my plan view, they're going to be parallel with the two surfaces. So one of the surfaces of the table is vertical, and one of the surfaces is horizontal. And that gives me VPL and VPR. That's me finished with my plan view. What I'll do is I'll untape it, spin it around, and retape it again. Yes, Oscar?
So what's the angle from A to the spectator?
This angle, 60 degrees. So if I just show you here,
Okay.
Sorry, sir.
is that okay? I'm going to try and keep as much of this on the screen as possible while still giving myself room underneath. So we line up our picture plane with the T-square. Tape off two sides of the page, making sure it's well stuck down. I have a slightly off, but I think I'm okay. And the table is going to be, the maximum height of the table is 50, and our spectator is 80, so I've no problems with the object being above the eye of the spectator. So I'll draw my horizon line. I'll step down by 80 millimeters. Drawing in my ground line upon which the spectator stands. Then we will have our reference height line, which is going to be in orange. Okay, so that orange line, and again, just slide this up so you can see it. Okay, so there's our reference height line. So any heights that are involved in this question, I'm going to mark on that line now, because if they were touching the picture plane up at corner A, this is the height that they would be. So we've 30, 40 and 50. So 30, 40 and 50. There's my three heights marked off. I'm going to use them a little bit later. So the vanishing point on the left, I'm going to bring that down. Again, using a different colour just to identify it. Bring it down to the eye of the spectator, or the eye line of the spectator. VPR, bring that down to the eye line of the spectator, and relabel them, because this is a different view. VPL, VPR. The base of this table tennis table would start from corner A and go to VPL. The base then would go to the right to VPR. The height of the table is 40 millimeters, so I'm going to take my 40 height and bring that towards VPL and VPR. Any questions so far? Okay, so there's my table disappearing until it hits the horizon, which is very, very far away. So now what I'm going to do is I'm going to level the corners of my table. I have corner A already. I go in a clockwise pattern, B, C, and D. So remember, that's going to create 8 points for me: one on the ground, one in the air, one on the ground, one on the air, one on the ground, one on the air, one on the ground, one on the air. Yes?
What year is this?
2012. Alright, now wherever it hits the picture plane, I've shared it in Teams as well, Camille, so if you go into Teams, I've sent a reply underneath the assignment. So we bring that down, wherever it hits the picture plane, bring it down, giving us the limit. That's where the end of the table is, or point D. So again, I label that as D and D. When we bring B to the eye of the spectator, wherever it hits the picture plane here, we bring that straight down. And that's going to be the limit on the left hand side, giving us edge B, and B. And what I'm going to start doing is I'm going to start drawing this in heavy detail just to make it stand out that little bit more. Just so you kind of understand what we're drawing. So this is the top surface of the table. So I have edge AD and edge AB. Again, that's A and that's A. B is parallel to D, so therefore it will travel towards the vanishing point on the right. And DC is parallel to edge AB, so therefore it will travel or vanish towards the vanishing point left, giving us point C. So there's the top of my table. I can draw that now in heavy detail. So at least I have the top of the table, and I have the 3 visible vertical edges. Now all I need to do is get the little V, if you look here, the little V cut underneath the table. Okay, so we're going to get that, and I'm going to transfer that to here. So what we do is, we know that that height is 30. I'll do the net then after this. So the height of 30, if it was here against corner A, it would be exactly 30. However, it starts here. So I'm going to go back that way, find this point down here, and then make it travel in that direction going towards VPO. So it vanishes back towards the horizon line. I'm going to call this point 1. Point 1 then comes to the eye of the spectator. Wherever it hits the picture plane, we bring it down vertically, giving us point 1. Okay. Now, if I wanted to call this point 2 and point 3, I'm going to do the exact same thing. The 2 of them are on the ground, so I'm going to bring 2 to the eye of the spectator. Wherever it hits the picture plane, we bring it straight down, locating it on the ground. There's point 2. We bring point 3 to the eye of the spectator. Wherever it hits the picture plane, we bring it straight down, locating point 3. 1 goes to 2. 1 goes to 3, and we will see 3 disappear back this way because it disappears back that way. So I'm going to bring 3 to VPO. That's the direction that it disappears, and that will be drawn in heavy in there. And these little small bits here will be heavy and heavy. So that's the cut taken out. You could, if you wanted to draw in the hidden detail, it's not required. But if I wanted to, the hidden detail of that would disappear in that direction, and the hidden detail of this would disappear in this direction. I just need to find the limit to it. So where does it stop? I apply the same situation here. So 1 travels that way, there's the end of 1, bring it to the eye of the spectator. Where it hits here, bring it straight down, giving you the limit of 1. Okay? The net is here, and I'm going to show you a new way to do this. Okay? I'm going to show you 2 ways to do it. So this net here is at a height of 50 along this way. If I call this point 4, I need to travel from A to 4, and then to get 4, 5, I need to bring 4 towards VPL down here in order to find 5. Okay? So that's me traveling from A. Imagine this is the top of your head. Okay, you're in an airplane looking at a person walking along the street. They walk from here to the street corner, and then they travel that way. Okay, there's buildings in the way, so they travel from here to here to here. That's the line we're looking for. Okay, so the net is not going to originate here. So the way that we would have done previously is I'd bring the height of 50 across, Okay? Bring 4 to the eye of the spectator. This is what we're used to. I bring it straight down. Wherever it crosses that height line of 50, which is here, I'm just going to dot that in because I want to show you another way to do it. That is the height of 4. Okay? And then we would make that travel towards VPL because 4, 5 is parallel to VPL, so therefore 4 must go towards VPL. The other way that we can do this, and I'm going to draw this in green so that we can see it visually, is if I continue 4, 5 on, and this is very, very commonly needed at higher level, okay? Where if I continue 4, 5 on to hit the picture plane, this is going to give me a second reference height line. So what I can do is I can bring that down to my ground line, and I can measure up on this reference height line, this second reference height line that I've created. I can measure up 50, which is the height of my net. Okay, you can see it there. That's 50. And what I do is if I bring that back towards VPL, which is this direction here, if I bring it from there back that way, it's parallel to VPL. You will notice that it will cross point 4 that I already found. So that there is the line, let's call it, we call it Z4 or Z5. This is Z, top and bottom of it, okay? Traveling along to VPL. And then if I want to find 0.5 on that line, it's the same thing. So there's just a new way to find it. I just created a second reference height line and brought it to one vanishing point rather than going towards one vanishing point and then towards a second vanishing point, which I did here. 50 towards VPR, stopped, and then towards VPL. Okay, so this is just one reference height line, one VP point. Alright, it's just a different way of doing it. It's very, very commonly needed in higher level questions, and that's why I'm introducing you to it. Okay, we still need to find the stopping point of 0.5, so I'll bring 0.5, or the end of the net, to the eye of the spectator where it hits the picture plane. We bring it straight down, and wherever it crosses the Z line, if we want to call it the Z line, is our net. So the net will run from here to here. That's 0.5, and if I've done it correctly, the bottom of the net here should cross that point there as well. Bottom of the net. We could continue on to VPL. Okay, and that's that question done. I'm just going to zoom in a little bit on the solution to help you see it.